Welcome to my channel. In this tutorial, we're looking at the integral of this rational function 2x to the third power minus 1 divided by x plus x to the fourth power. So how do you do this? This one we can use u sub, but we have to divide the numerator and the denominator by some factor. So let's do that and see. Let's divide both numerator and the denominator by x squared. So this integral of 2x to the third power x plus x to the fourth dx, if we do that, that will be 2x to the third power minus 1 over 4 all over x plus x to the fourth power all over x. We are dividing by x squared all over x plus x to the fourth over x squared dx. It simplifies to 2x squared, so that should be 2x to the third power over x squared minus 1 over x squared all over x squared plus x to the fourth over x squared dx. What does that simplify to? 2x to the third power divided by x squared, so that is 2x minus 1 over x squared all over x divided by x squared is 1 over x plus x to the fourth power divided by x squared, so that is 2x squared dx. So we can now use a u sub here and hope for the best. This is very easy. Let u to be equal to 1 over x plus x squared. And after this, du dx is what? So that is negative 1 over x squared plus 2x. So this is like x to the power negative 1. Bring the negative 1 in front, x to negative 1 minus 1. As negative x to the negative 2, which is negative 1 over x squared. So that is how you differentiate 1 over x plus the differential of x squared, which is 2x. And now if we look at the denominator, what happens there? At the numerator, I mean. So here, du is now equal to 2x minus over x squared all times dx. It implies dx is equals to du all over 2x minus 1 over x squared. So it means in place of dx, we can just plug in this. So our integral, which is the integral of 2x minus 1 over x squared, 2x minus 1 over x squared, all over 1 over x plus x squared dx is equals to the integral. I'll maintain the numerator for now, divided by 1 over x plus x squared from our u sub. U was equal to 1 over x plus x squared. So in place of 1 over x plus x squared, we just plug in u times dx. What is dx? Dx is what we found here. Dx is du over 2x minus 1 over x squared. Some things will cancel out nicely. This cancels that with the integral of 1 over u du. So this integral now evaluates to integral of 1 over u du, which is the natural logarithm of the absolute value of u. But we plug back our u u was 1 over x plus x squared. So we know that from our u sub u was equal to 1 over x plus x squared. So therefore implies that the integral of 2x minus 1 over x squared all over 1 over x plus x squared dx is equals to the natural logarithm of u, and u is 1 over x plus x squared. But this one, the integral of 2x minus 1 over x squared over 1 over x plus x squared is the same as our original integral, which is 2x cubed minus 1, 2x cubed minus 1 all over x plus x to the 4th power, x plus x to the 4th power dx. These are the same, and the answer to that is the natural logarithm of the absolute value of 1 over x plus x squared plus the constant of integration. So this is our final answer. So we can verify again ddx of the natural log of the absolute value of 1 over x plus x squared plus constant of integration. This one should differentiate to this. Yeah, so this is our answer to the integral we are asked to integrate. So if you find this video helpful, make sure to like the video, subscribe to my channel, and hit the notification bell for more content. I'll see you in the next one.